on our YouTube channel. This is Matt Schuman with ATA Engineering, and I have with me today Jessie Belden as well, and she's going to be going over catching design issues early with NX HD3D, advanced visual reporting. But I just wanted to give a quick overview, a bit about who ATA Engineering is for those who aren't maybe as familiar with ATA. So we're an engineering services company as well as a value-added reseller for Siemens hardware and software. And I'll go through on the next slide. Our roots go back over 4 decades. We specialize primarily in aerospace, satellite, and defense. These are some industries that we work a lot with in test, analysis, and design. But beyond some of these, as well as theme entertainment and high-speed systems, we also work with other customers in heavy equipment, off-highway, medical device, for example. Who we are, we're an employee-owned small business with over 200 full-time staff, many of whom have advanced degrees and expertise, specializing in lots of different aspects, thermal and structural, fluid flow, and so on. So we also service Siemens software and hardware across SimCenter simulation products, such as SimCenter 3D, FEMAP, Nastran, NX, which we're going to talk about today, Teamcenter PLM, and we also have test and measurement hardware and software tools. This shows a history on ATA Engineering that dates back to 1967, so more than 4 decades old now, where ATA's roots were founded on structural dynamics research, specializing in advanced test and analysis. And throughout the years, in the mid-2000s, we became well known for supporting the NX product line, which is what we're going to be talking a bit about here today. So for nearly 2 decades, we've supported Siemens NX. And as you can see throughout history here in the time around 2016, when Siemens acquired the computational fluid dynamic tool called STAR CCM Plus from CD Adapco, we started to support and resell that product. HEEDS coming along with that as well. And in 2021, we became the first US reseller for SimCenter testing solutions, SCADAS hardware and test lab software. And we continue throughout today supporting these tools. Our engineers use these tools day in and day out. So we support many of these products. And for more information on these products and services, you can go to our website at ata-e.com, and you can scroll through and see the various services and products that we support, and you can click on that and submit, and we will respond back to you with more information. So with that, I'm going to introduce Jessie Belden, who joined ATA a few years ago. Jessie is an engineer with several years of experience using Siemens NX for computer-aided design and aerospace structures and themed entertainment. She holds an expert level certification from Siemens for NX and is proficient in various other accelerator programs such as the SimCenter 3D tools and SimCenter Motion. Jessie holds a Bachelor of Science and her Master's of Engineering and Mechanical Engineering from Rochester Institute of Technology. And this, if you have questions as well after this webinar, feel free to reach out to us at sales@ata-e.com. You can visit us on the website at ata-e.com as well. And with that, Jessie, I'll turn it over to you.
All right, thank you, Matt. I'm going to go ahead and share my screen here. So I've got just a few slides. We're going to walk through the slides today and kind of be bouncing back and forth between slides and actually open up the NX program to show you some things around. But all of today is based around using the HD3D design toolkit. And so that is one of our kind of built-in functions into NX. So we'll walk through a lot of visual validation tools that are going to help you make sure that your design is staying on track and you're running through what we like to call your digital design reviews. So first up, just talking a bit about what the toolkit is, and then as I mentioned, I'm going to be going over, there's a few different tools in the toolkit itself. I'm going to be going over 5 of them today. This visual reporting, checkmate, corrosion risks, and then 2 within kind of the PMI category. And then after the demo, we've got some time. You're welcome to ask any questions about the toolkit or other NX things you got going on. First up, about the toolkit itself, as I mentioned, you can access it through your sidebar. So all the tabs that are on the very left of your NX screen, this one that looks like an eye icon with kind of signals emanating from it, that's going to take you to your HD3D tools and open up this whole toolkit of different applications that you can look into. It's essentially going to keep everything in one location and making sure that you're checking things in the design phase, the analysis phase, the manufacturing phase. Really, all of these tools have their own use. Some of them can be brought in throughout the entire design process. Some of them are probably best brought in from the design standpoint or from the manufacturing standpoint. But really, all of them are super useful in terms of just running some things through checks, making sure that you have it marked off everything that you need to. You've run everything through your sanity checks, your gut checks, and making sure that nothing's colliding, nothing's going to corrode, things like that. Um, each one of these applications, some of them come with fully just out of the box options, and so that's in the sense of kind of like a plug and play. You click, I want to run a report on my weight budget or my component categories, things like that. Or you can create fully customizable checks if there's something that you or your company likes to run on every part, or the specific part, and maybe the out of the box options aren't quite getting the exact data that you want. We have ways to kind of extract that information so that you can make sure that you're getting the data that is important to you and to your company. What's also really nice is some of these play very well with Team Center. So if you have, Team Center integrated into your NX, some of these toolkits are prime candidates for loading up Team Center and being able to track issues simultaneously between different programs and versions. The first tool we're going to talk about is the visual reporting tool. This one, and I would say the next one we'll talk about the checkmate, or kind of Siemens 2 big favorite tools within this toolkit, things that we really like to use a lot and that are some of the most, they're all kind of user friendly, but these are 2 that we really encourage people to use and to learn. So this one is going to do a really great job of creating nice visuals based off of your assembly. So it's going to color code things, and it's also going to label things. So you can see here I've got a picture. It's color coded, and then each color and object has a pound or kilogram weight tag attached to it. That's something that you can customize. If you want to turn the tags off, you can turn the tags off. If you want to turn the color off, you can do that. If you want to show both of them, you can. But this tool itself can be used on parts or bodies or faces or assemblies, anything that you kind of want to group by categories and color based off of whatever that category is. What's really nice about this is that you can grab a screenshot or have NX export an HTML file. And so that file can be viewed from any computer. You can send it to your manufacturing shop. They don't need an NX license. They don't need to have your part file. They can just load up the HTML report and see all of the colors and the labels and things like that. You can also create custom reports within here, so you can pull data from NX or Team Center or even some of your system properties. And that'll allow you to just kind of, if, like I mentioned before, if none of the out-of-the-box tools are exactly what you're looking for, you can come in and create a custom field that's more applicable to your part or your company. So with that, I'm just going to jump into NX here. Can you guys see my, Matt, can you see my NX screen? Okay.
I can, Jesse. Yep, looks great.
Great, thank you. So this, I'll touch on this really quickly before we dive too deep into visual reporting, but this is your HD3D toolkit. Like I mentioned, this kind of eye with signal icon out of your tool taskbar on the left-hand side. And so if you open that up, you can come into this. There's visual reporting is what I'm going to jump into, but I wanted to touch on just the fact of how many tools are in here. like I mentioned, there's about five that I'm going over today, but the ones that I don't go over, it's still nice to know. It's, I recommend looking into if any of it sounds appealing. But um, things like the issue management, that's one that I was talking about that works very nicely with Team Center. So this is a way to kind of capture and track all of your design changes, your engineering changes. You can kind of pair that with a Team Center file and then always be able to reference, what you can drop in the PDF into Team Center and view the ECN, or just making sure that you're keeping track of where this is at the design process, and that every related file is kind of following along with it. Um, Another really cool one is the vehicle packaging validation. So this one takes standards for any kind of vehicle, like a big semi truck or an excavator or a car, and helps you see it'll visually show out a map of what the driver can see based off of the windshield range, the rear view mirrors, the side view mirrors, whatever they're showing you where the blind spot is based off of your any kind of trusses or anything like that. um, and so that's actually pulling from relevant automotive standards to and biological standards of trying to get where everyone's field of view is. So that's a really cool tool. Like I said, I won't be going over that today, but there are plenty of other options within the HD3D toolkit of fun, useful task tools that you can have access to if you just open up your taskbar. So the first one that I said we were talking about is visual reporting. This is the one that's going to give us the pretty colors and the nice labels. So one thing we can do here is you can see these are all my out of the box tools reports. And so we've got a bunch of, if you want to see what the mass status is, does it have a material assigned? What are the areas? You can actually link it with another tool we're going to talk about, checkmates, and see color code it based off of the results of whatever you're checking. One thing that I'm gonna go over here is the component group. So if you just come down at controls and you say activate, it'll color code it. So I have this set up to run through an electrical, a manufacturing, purchase parts, tooling parts, and color code everything based off of that. So you can see like my battery down here is maroon because it's part of the electrical system. If you come up to your tabs up at the top and you say click on visual reporting and say explore report, that'll kind of allow you to delve deeper into this and explore some of the report in detail. So if I want to isolate, let's say, my electrical system, I can come up here and click that, or my manufactured parts. What's also neat is if you go back to your assembly navigator, it's isolating those manufactured parts so that they're easy to see and easy to reference. If I change it to purchase parts, it now loads up all my purchase parts. Um, so that's really cool. And then if I look into, I was telling you we can save these reports. So maybe I'll go back to all of my components, and this is where you can say, do I want to color objects? Do I want to tag objects? Um, you know, Whatever is most useful to you. We're going to just say colors for now. But if you tell it where you want to output your report, you can come in. I just have it saved to my demo directory here, but you can come in and right click and say create HTML report, and it'll go ahead and create that in your file. And it'll throw out a few different things for whatever is most useful to you, but I like the PNG because it's going to show you, I've isolated my electrical system, and so that's kind of the visual that it's going to output. But, or sorry, I was highlighting the tooling, which is why the tooling was highlighted in blue. But so those are, that was one of our out of the box tools. I can go ahead and deactivate the report and it resets everything back to normal colors. But I also mentioned that you can come in and create your own report. So that would be down here. It says define new report. And you can come in and tell it, are you pulling from a component or a subpart? Are you looking for like a part attribute, something like your mass or uh, let's see, component property. You can come in and pick center of mass or, what is the load state? Is it fully loaded? Things like that. So you get to choose. This is when you're defining a report, a whole new report. You get to choose whatever you're looking for. And as I mentioned, you can pull from, Team Center. You can pull from NX. You can pull from your system properties to create a whole new report. And so I'll go through an example, one that we have. You say open report from native file system. I've got a report saved to my folder, my demo folder. I've got this wait field that I'll go ahead and run. And I'll say run. And so what this does is I customize this to say, put everything in one mass bucket from 0 to 0.5 kilograms, make that blue. The next bucket, 0.5 to 1 kilogram, make that this kind of yellow-green. And so you can go ahead and this is not an out-of-the-box tool. This is something that I set up just based off of how I wanted to categorize these weights. So that is something that you can do. Like I said, it's fully customizable, and whatever information you're looking to pull and to color and visualize, that's easy enough to pull. And so next up, I'm going to talk a little bit about Checkmate. So this one has, I want to say, hundreds of out-of-the-box checks. You'll see the variety when I open it up on my screen. But it covers anything from taking a look at your drawing status. Do you have dimensions in there? Are all of your wave geometry links updated? You can check something in the model documentation or the geometry itself. You can figure out, is anything interfering? Has your clearance analysis been run? What's your part file structure like? Do you have expressions? Are they being used correctly? Things like that. What's also really nice is that when you run these checks, let's say, like I mentioned, there's hundreds of checks. If you want to pick, let's say, 5 that you always want to run on this part, you can actually save it to the part itself. And so that way, if I run a part and run my checks and something's failing, and I pass it off to a coworker and I say, hey, my checkmates told me that the clearance analysis hasn't been run. Can you please run that and rerun the checks just to prove that it's set? So my coworker can see that what my checkmates were, what I was running, and it was saved to the part. And so when they update it and I bring it back onto my screen, I can see that the checkmate has now been rerun. And after the clearance analysis has been run, I can see that that check will start passing. You can also author custom checks, similar to what we were doing with the visual reporting. This is for something that's a bit more. It falls under a different license or token. It's a separate add-on, but it's a little bit more code based. Whereas the visual reporting was, you could see, it was mostly a drag and drop system of menu items. The checkmates are a bit more actually needing to be coded, and so that is something that you would want to have someone who's got a bit more of a programming background check out, or someone who is mechanically inclined and willing to learn that. But so I'm not going to delve too deep into how to actually author those checks, but that is an option if you're looking for it. As I mentioned, there are plenty of out-of-the-box checks that should hopefully cover most of what you need. And if not, if there's something that your company specifically wants to check, then you can go in and create your own. So you can see right now I'm still in my visual reporting tab. If I click this little power button, it's going to say deactivate. It'll bring me back to the HD3D toolkit, and I can click on my checkmates. And so this one, you would come down here. You can choose, what information you want to show. Does it pass? Show me anything that's passed with a warning. Show me anything that's failed. Show me anything that has passed fully. And you can uncheck those if you are running many tests and you don't want to see the ones that passed. To say, okay, that's out of my mind. I don't need to see that right now. You can unclick that, and it won't show those in the report, even if, let's say things have passed. It won't show it, just so that it's not clogging up your report running. But this first step is to come down to set up tests. If you click this little toggle button and you go to tests, these are all the tests, and each one has a drop down. So you can pick, get information is really populated. You could look at expressions, and maybe your company has a standard where we're not going to have any unused expressions in our part because that's just going to create confusion. You can check, are there any unused expressions in my part? You can come down and say, does my drawing at least have a dimension? Because if it doesn't, then maybe that drawing's not as far along as we had hoped it was. Like I mentioned before, you can check the wave link status. So anything that uses a wave geometry linker or product interface, making sure that those are fully up to date before you send out a step file. Because if it's not up to date, you might have something that's not correct in your part. And so you can do things, and each one of these drop downs has some more information. You can come down and check in for modeling, and um, come down to my features and say, uh, check my blends, check my referencing. Um, and anyway, so there are a bunch of out of the box checks. I recommend looking into it and trying to figure out if there is something you like, if there's a check that you think should be included. Maybe every time that you submit a part to manufacturing, you want to run XYZ checks to make sure that you're catching anything before it goes out that's, maybe have slipped through the cracks a little bit. And when you feel like you're ready and you've collected all the tests that you want to run, you can hit execute checkmate tests, and it'll go ahead and run that. And so mine passed, but they passed with information, saying it's run in just this session, because that's all that I have open at the moment. But I was mentioning you could author checks. So anyway, this information is stored with the part itself, as I was talking about. So if you send this off to another coworker, you have them open up the part. If I were to save this, they would be able to open it up and see the checkmates that I ran. To author checks, you want to come up to your developer tab up here, which you might not have. You might have to go looking for it. So if you come up to your taskbar, you right click and say customize. You can go to tabs and bars and find the developer tab. And so if it's unclicked, the developer tab is hidden. If it is clicked, then you can see it. But if you come up to the developer tab, there's a few different checkmate categories. You can see this author tests. And so we click on that. And there's a few ones where you can actually edit or do kind of like a save as of the existing templates if there's something that you want to start off from. But then we also have this create edit checker. And so this is fully customizable. This is starting from scratch. Give it a name, give it a category, what little submenu should it fall under, if any, and kind of describing, what attributes you're going to pull in, things like mass, density, volume, uh, and then come down here and actually author the checker. And so this checker is kind of based off of its own language and function generator. So that is, like I said, I'm not going to delve too deep into that, but this is how you would go about authoring new tests. And that's our checkmate tool. Next up, I'm going to talk a little bit about our corrosion analysis tool. So this one is really neat. You can run it on your assemblies, and it's going to run through a check of if your parts are at risk of corrosion based off of the material properties that are assigned to them. And if, you can choose what kind of different categories you want to rate your risk in, because most things, it could have some risk, but let's say it's not going to be a risk for thousands of years, then that's not something you're going to concern yourself with. And so you can kind of categorize color wise based off of what that risk is. Tell me anything that's less than a 0.1 risk, and show me that, or don't show me that, things like that. Anyway, the corrosion tool itself pulls data from the material properties that are in your part file. And with this, everything that the galvanic data that it's pulling is from the Cordesa GIN database. And so with that, means to you is that you have to have a material that has that database and that property built into it. Luckily, NX kind of comes default with that material built in. So within your NX file structure, there is a Cordesogen uh, database for materials that you can just use by default, and it has most generic materials. If that doesn't work for you, there's also a way for you to map material data. So you can say, let's say I have an aluminum 1775 and maybe the material database doesn't have that in there. It does, but I'm just using it as an example. Um, you might tell it, okay, instead of not knowing your galvanic risk, you can pull the data from, let's say, 6061 aluminum and tell it that it's close enough, and it'll be able to use that as a reference. And so you can map your own personal materials to the Cordesa database. You have the option to present the results. I was talking about that scaling of what is and is not at risk. You can either do a custom scale of setting limits and having it display red. Red is anything that's above your limit, yellow is anything in between your limits, and green is anything below your limits. So, safe from corrosion in your mind. Or there is a mil spec that controls corrosion analysis, and so the mil spec kind of lays out its own color coding and level of risks, I should say. And so you could choose to follow that coloring and coding if that's it's a little bit more defined, and it's easier to back up because it is an existing standard. So you have the option to use that. What's also really nice is within NX itself, it's easy to change materials, and it's also easy to apply coatings. And so just as easy it is to change those things, you can then come back into the corrosion risk tool and rerun it and see how those changes have affected anything. So if I choose to make this out of 6061 instead of 7075, is that something that's going to get me there, that's going to get me close enough to passing, or do I need to completely switch to a steel, or do I need to apply some sort of like zinc coating? Things like that are just useful to check, and it's nice with because of NX's ability to quickly interchange between materials and add coatings. It's just as easy to rerun the corrosion analysis and check that how that affects things. So we will jump back into NX. This one, I'm going to open up just a different model that I've got going on here. This is just a drive base that I made, but you can see I've got a bunch of different gussets. I've got some box tubes, some wheel brackets, things like that. And so if I come down to my HD3D tools, I'm going to jump into this corrosion risk analysis. And you'll see the first thing that it asks me is what I want my electrolyte to be. I have this 3.5 NaCl, or I have the military standard. Depends on what you want to use, what your company wants to use. I'm just going to use the 3.5 just as an example. And you can select components. Maybe you're only interested in this one corner, or let's just, for fun, we're going to say, let's just analyze the whole thing. And you'll say, okay. And then, so it's picked out all like the face pairs, everything that's touching each other. And you can say calculate. It'll run through, and it's got, so you can see down here, I've got my risk limits. So I can either do a custom, level of red, yellow, green. Anything that's, below 1 is going to be green. Anything that's above 10 is going to be red, and anything in between is going to be yellow. And you can turn off or show only your high risk items. Let's say you don't really care about looking at the green items. You just want to know what's high risk. Or you can jump over to your mil spec. And this has that kind of built-in galvanic rate system that I was talking about. And so, a 0 to a 6 risk, and it'll color code things based off of that. So you can see I've got a few different colors going on here. Let's say one thing that's interesting is I have some brackets that are titanium 6, and those are at a decent risk. I mean, it's not the lowest of low, but it's pretty low. It's at our rating of 1. So that's good. But then I noticed that my titanium 3 is a much higher risk. And both of them have an aluminum 2024 anode, but is it intentional that I have titanium 3 at these brackets? Maybe that was a mistake. Maybe someone meant to put titanium 6. Or I was going to go with titanium 3, but that's clearly not cutting it, so I need to switch to titanium 6. That's no problem. We can come back in. We'll open up that gusset. That's our titanium 3 and come to our materials. We'll say assign materials. And so this is where you can pull in that cordesogen database. So you can click your site matml library and browse for your folder. It's going to be within your NX directory. If you go into NX Design Tools Corrosion, it comes with this corrosion materials and corrosion coatings. So if you select corrosion materials, these are ones that are going to have that built-in Cordesa database. So it's going to know what your galvanic corrosion risk is. So these were titanium 3. I'm going to switch it to titanium 6 and apply it to this body. And we'll save it and see how that does. If we go back to our HD3D tools, back into corrosion, I like to just kind of start fresh. So I deselect everything and then reselect it and say, okay. So once again, it's found my body pairs. I say calculate. And you can see, hey, wait a minute. This still thinks it's titanium 3. So that you need to come in and say assess corrosion material because its physical material wasn't lining up with the corrosion material. And so you can just click in. Oh, that's my L gusset. My T gusset. This is what I'm looking for. Assess corrosion material. You can come here and click on corrosion material. You can say it thinks its physical material is titanium 6, which is what I want, but its corrosion material still has that titanium 3 left over. That's no problem. We just come in and click titanium 6, and now it knows that's what it is. So you can see that these have now turned into more of our lower risk items. Alternatively, right now, this has the aluminum, like the box tube, as the anode, and the titanium as the cathode. And what that's telling you is that the anode, so the aluminum, is going to corrode faster than the cathode, the titanium. That's not something I really want. I'm of the mindset of these brackets are a lot easier to replace than the box tube is. So if that's the case, maybe I could try out a coating and try to see if putting a coating on the T gusset will help and switch the order of what is the anode and the cathode. And so if we come over to our T gusset, if you want to add a coating, that's the same thing. There's another tab, you might have to add it, but it's just called coating. And you can create a coating region, so which faces are going to get coated. I'm going to say the top and the bottom because I want to make sure that my assembly team can just plop it into place, not really have to think about what direction it's facing. And I'll create a new region, and I'll say coating layer, and add another material. This is, again, you can pull in your site ML library. And so this is going to come into our corrosion coatings. And so if we open up that database, we can see I've got this zinc nickel that I'm going to apply. And you can see it's turned it I had it color my coating black just so that you could see. And if you come over to your drive base, and same thing, back into your corrosion risks. And run that again. You can see I now have my zinc for my T gussets. I've got my zinc as my anode and my aluminum as my cathode. So now if anything's going to corrode, it's going to be the gusset. And so that's what I would personally rather replace. So, just things for you to think about when you're designing parts, how to make sure that it's going to achieve the life that you want it to. And if you can't get it to achieve the right life, then, think about if something's going to corrode, what would you rather it be? And so that's what's really helpful about the corrosion risk. It's going to tell you about what rate you're going at, and you can be able to try out, okay, let's try this material, let's try this coating, and seeing how that affects your assembly. And is it getting you to a part where something is acceptable, or you're going to, either nothing has to be replaced, or you're going to have a maintenance plan of, okay, this is going to corrode fastest, and we're going to have X amount on hand to replace that as needed. So the next two, they're both pretty short. So I kind of looped them both together. They both fall under the PMI uh, category. And so the first one is the PMI advisor. And so PMI is, if you're not aware, it's kind of like a drawing in 3D. So you can see I've got dimensions, I've got datums, I've got tolerances, whole call outs, things like that. So it's essentially if you want to put all the data that would go into a drawing onto your 3D model, and so it's a little bit easier to see visually. You can send it to a machine shop, and maybe they're able to understand it a bit better looking at the 3D model than they would have as on a 2D drawing. Anyway, if you have a PMI on your part, but maybe you're a bit new to this, or you're not entirely sure, you just want another gut check to make sure, am I doing this correctly? Am I applying my dimensions and my datums and my GD&T in a manner that's consistent with applicable standards? We have our PMI advising tool. And so this, similar to how your drawings are going to be based off of the usually like an ASME Y14 standard, there are 3D PMI standards, which is what the PMI advisor is going to check against. And so you can see here, it's going to either put check marks like, yes, this looks good to me, or red X's are going to tell you, okay, you might be missing something, or you might not have your tolerance applied correctly, or something like that. There can be like warning symbols saying, hey, this does pass, but here's a better way to do it. And so this tool is going to just go through your PMI features and offer suggestions as to how you might improve it, or if it looks good. And you can, as talked about on our other reports, you can kind of toggle on what you want to see. So if you don't care if something passed, you can toggle that off, and you won't see all those green check marks. And then similarly, we have the PMI compare, which is really great with Team Center because Team Center stores past revisions. So you can store like a rev dash, a rev A, a rev B. And the PMI allows you to pull up both versions and tell you what has changed. And so you might pull this up and say, it might tell you this dimension was added, this dimension was changed, this dimension was removed. So that way, if I make some changes and I run my PMI advise and it's telling me, oh, I need to add a tolerance here and, and add a dimension here, I might be a little bit too busy to handle that myself. I might pass it on to a coworker. They make the changes and pass it back to me, and I want to make sure that they've made the changes that I was expecting and see what the difference is between my part and theirs. The PMI compare is going to allow you to do that easily and pull up, you don't have to go through and check every dimension yourself. You'll just be able to visually see what is new and what's changed. I mentioned that works well with Team Center, but if you don't have Team Center, that is also okay. You can, if you do like a save as on your part, and so that you have a historical record of rev dash, rev A, and rev B on your file system, you can bring those up as long as you haven't overwritten it in the part. You can bring those both up and evaluate that as well. So to show you what that looks like, I'm going to turn off my HD3D, and I am going to open up my wheel bracket. So you can see here, I've got some PMI already set up here. I've got a few dimensions, some datums, things like that. And first up, the PMI advise. I want to know, am I on the right track here? Does this look okay? So I'll come back to my HD3D tools and open up my PMI advisor. And so you can see I've already run it, but you would just come down and run advisor check. And so it's going to tell you this datum checks out. Something's wrong with this dimension. So I might say, okay, what's going on here? And it says this dimension should have a tolerance or be basic. I say, okay, oh, right, I forgot to add a tolerance there. And same thing here is there's a missing a tolerance, or maybe it should be basic. This is where I was saying you could customize, like if I unclick show past, maybe I don't want that clogging up my screen, my report. Just take a look at what's in need of attention, or maybe I do want to see, what's okay. And so you can show all of those as you wish. But let's say I've run this advising and I realize I have to make some changes and oh, maybe I forgot some dimensions as well. I can come up and if we open up, I have a Rev A that has new dimensions and datums and different PMI features. I can open up PMI compare. And so right now, because I'm on Rev A, it's the part that's the baseline part. But then I can select what parts I want to compare it to. I can bring that back to my initial, no rev, which it would be a rev dash, and say okay. And so it's going to open them up side by side. And so you can see I've got a green plus is saying that this dimension was added. A green plus, I previously didn't have a thickness or a height defined on these tabs, and now I do. And this one changed. It changed. You can see it says following properties change tolerance type. So you can see I've now changed this to a basic dimension to kind of clear that check that was being run earlier. And this one is also changed to tolerance type, and I've added, my plus or minus tolerances there. So you can easily see what's been going on and what the difference is between the two. And then if you are interested, you can come back to your Rev your Rev A, rerun the advisor, and say, okay, most things have passed. What about this new dimension that I added? Should this have a tolerance? But it's a reference, so it might be okay. But that's what the PMI toolkit looks like. And so that's the main ideas of those 5 tools that I've gone over. Really, what we're hoping you pick up is that the HD3D tools are very useful for doing any kind of visual data reporting, doing some gut checks, and making sure that your part has passed all the quality checks and whatever design requirements you have, or your company has, or your client has. There are many, many out of the box tools that you can just easily plug and play and run it super quick. Or you can go in and even author your own checks or your own reports if that's something that is interested. If, what NX's defaults aren't quite meeting your needs, you can go in and customize things to make it so that you're getting all the information you need. You're making sure that your parts have any kind of checks run and that they have the data that you're looking for, that it's up to date, that your PMI is accurate and has passed the advisor checks. And so really, it's just an overall great way to give your parts a good design check before they hit the manufacturing floor, before they're out being processed. You can save yourself a lot of time and money if you're checking these things digitally beforehand versus waiting for a part to come back to you. And so with that, I think we've got some time. I'd open it up to questions if anyone has any. I'll go ahead and stop.